Thank you, everyone. Rodrigo Belisario from Titan America. We're a cement company with operations in Florida and all the East Coast. And I'm gonna be here talking about alternative fuels and raw materials, what we can do to contribute and to help on this particular case of hurricane debris. Next slide. Sorry again. So Titan America, it's a major cement producer in the East Coast of the United States. We have the largest cement plant in Florida. Probably you have seen that, and next to the turnpike, we're getting close to Miami. Produce 2.3 million tons of cement per year. And since the mid-2000s, we have been working with engineered fuels or use different streams that for some people are not useful and use it as a fuel or as a raw material for our manufacturing process. And a couple of years ago, around 5 years ago, we started the process to build the infrastructure to produce our engineered fuel. And in 2021, we finally commissioned that plant with an investment of $25 million. And where so far we have been able to substitute 30% of our fuel needs for our manufacturing process. And we're going to talk a little bit more about what that manufacturing process is, how energy intensive it is for us. And we are proud to say that we have the most aggressive sustainability goals in all the Florida cement companies. We are the first company 100% producing limestone cement, which is about 30% less energy intensive than the regular cement that has been commercialized so far. So what is the cement? How can we make cement? We're always looking for sustainable materials and fuels to combine with our process. Basically, and the process starts with a quarry where we bring the limestone and crush it to 3 inches minus and into a system. And then we add some supplements like iron, silica, and alumina. And by the way, these supplements not necessarily has to be virgin materials. We use fly ash, for example, roughly 250,000 tons per year of fly ash from coal fire plants. And we use copper slag as an iron source and so on and so forth. No? And after that material is pretty finely grinded to a powder, is moved to this preheater system where roughly comes down to 600 degrees and up to 1600 in this area around here. And then it starts going to the rotary kiln where the clinker production starts, approximately to 2800. The material, the gases that are produced or the gases that are used to this process are roughly at 3500 degrees or 4000 degrees. And the good thing about this, and I'm going to go a little bit on that later, is that there is a lot of material coming in, and the high temperatures and high residence times make it a great process for different streams and different ways. After the material is coming at the end of this little tube here, is cooled very rapidly in a matter of seconds to about 300 degrees, and then it's transported and crushed and grinded with gypsum, limestone to make the final product. That is what you see on the bags, typically in Home Depot on the big box stores. Now, why cement? This is one of the 100% truly recovery solutions. No? Basically, our process started, as I said, about 600 degrees here. The material comes down to these different vessels, and while the flow of hot air comes in the opposite direction. Okay, and at this point, where we call the pre-calciner, where most of the different waste that we use as a fuel and are introduced to the process, we have a temperature about 900 to up to 1600 degrees at the beginning here of the kiln, where we also feed some other type of fuels. And we get at the end the main burner here, where we also feed some fuels or some alternative fuels into the system. The flame goes to 2,000 degrees Celsius, and the gases up to the material up to 1,450, which is about 2,400 degrees. We are right now permitted for non-hazardous waste, and so we use, at the end, plastics from different companies or different sources, MRFs, and CNDs, wood, and some others that I will talk a little bit later. As you can see, here is the profile of the temperature in the kill zone with this. These are one of the benefits of the co-processing in cement kilns now. Long residence time at very, very high temperatures, so we guarantee the complete destruction of all the organic materials that are there. The combustion is rich in oxygen and active lime, so it's a very alkaline environment, so we are able to neutralize any gases, acid gases, SOx, or hydrogen chloride that might be in the system. And one of the most important ones is the ash is molecularly entramped or incorporated into the clinker matrix. The clinker is the product that comes out of this little tube here, and basically is completely molecular entrapped, so no leaching. No matter how fine we cross that material, never is going to leach. On top of that, we have 24/7 continuous monitoring of the emissions out of the plant. So we measure CO, CO2, volatile organic compounds, and NOx, mercury, and all this. And what we did, again, 5 years ago, we started this journey. We finally commissioned it 2 years ago, and we have what I would say is the state-of-the-art and the most modern facility in the state. We have our primary, secondary shredders, all the whistles and blowers, and eddy current, wind shifter, adjustment bunkers for moisture, and we have a scanner, optical scanner for quality control. We monitor the chlorine level and the moisture level all the time, an automated operation 24/7, and basically a very competitive price versus other landfills or other disposal solutions. We have a capacity of around 150,000 tons per year processing here. Right now we are around 60, 65, so we have a lot of room to grow. Now, how can we help? How the cement industry, and particularly our plant in Miami, can help in this? Basically, this is our hurricane debris. These are pictures, actual pictures from Hurricane Ian. However, we can mix that. This is the same, hurricane debris is just a mix of commercial, industrial, off-specs materials that we currently use. It's a mix of CND, wood, plastic, textile, carpet, roofing, plastics from CNDs or from rejects, agricultural biogenics, wood, biomass, yard waste, tire chips, some of the fuels that we use on a regular basis, recycling residue. One of our main feedstock right now for our plant is the reject of the MRF in Miami of rooters that we talked about a few days ago and yesterday. Okay, and at the end, we take all this, we pass it through that 25 million investment that we had there to produce this. Basically a fluff material that we can blow into our kiln and substitute our traditional fuels like coal or natural gas or whatever we use. Okay, with that said, you have any question? I'll